Welcome to the Friday seminar. My name is Miguel Figliosi, Civil Engineering Faculty, and with Liming Wan from Urban Planning. He's not here today, so I'm presenting our speakers. We run the seminar in the fall, and today we are very lucky to have two speakers from TriMet, Steve Callas and David Crout, and they will be talking about applications from the data they are collecting every day, megabytes and gigabytes of data that it's being collected, and we're very happy to have them here. TriMet has a lot of great people working and great collaborators with PSU, and I think everyone should recognize how much they do for public transportation in the region and how progressive they are. So
great. All right.
Thank you for being here.
All right. Thank you, Miguel. Thank you for having us. Dave and I, for those who don't know, Dave and I work in the Operations Analysis Division. So we're going to specifically talk about our CAD AVL system and the data and some applications that we use with the data. So for some of you who don't know what the acronym is for CAD AVL, but that's our Computer-Aided Dispatch and Automatic Vehicle Location System. So, and this is what I'm going to discuss today, is what's on our bus side, because our rail system has something a little bit different. But going back, is we've actually had a dispatching system that's been providing us data going back from the mid-90s to 1997, I believe, is when we started. However, our new system that we're upgrading now is completely different. It's providing us a lot more real-time tools for our dispatchers, as well as providing us same data that we had before, but a little bit of upgrading and enhancements to it. So let's see if I can do the slides. So as I mentioned, just a little bit of background of what the CAD AVL does. The primary source of it is to provide dispatching to and from our bus operators. So it does real-time vehicle location. The new system now will enable us to do a lot more headway management than the old system. The old system was primarily just a communications tool, so pretty much talk back and forth between bus dispatchers and operators, and they knew the location, but it was primarily just on an app or on a map. There were no real applications to be able to manage the system in real time. And the new system, which I have some screenshots to show you, will enable us to do that. Again, the digital voice data communications, one of the primary reasons why we had to upgrade this system is by the end of the year we're required by the FCC to get off the narrowband 450 megahertz system. So now we're upgrading it to a digital 750 megahertz system. I believe that's right. And that was one of the primary reasons why we had to do it. So plus our old dispatching system as well, too, is pretty much on its last legs. So we decided to upgrade everything at the same time. Again, enhanced security with the system as primary. And the other thing, too, is this data, this system is the backbone of all of our other ITS systems. So it provides information to all the downstreams, which includes TransitTracker. It makes the automatic stop announcements work, signal priority as well, too. It's the backbone for that. And plus, what we're going to focus on today is it collects a huge amount of operating data. So what I thought I'd do, first of all, just because it is a new system and we'll be able to manage, I thought you'd be interested in seeing what the CAD AVL system looks like and some screenshots of how we're going to be able to manage the system a little bit more in real time. So first, just starting off with the operator display. This is pretty much what the operator does see when they on their vehicle, the VCH they call it, the vehicle control head. This is how the operator communicates back and forth in dispatch and what they see. So what we have here is what's about this is it will actually show you the stop that you're at now, as well as how far away you are from the stop. And also what's new about the one as well, too, it will provide you the next 3 stops that are coming down the line. So you can actually get an idea on how distance and how far you are from the line. So it really helps the operators navigate the route much better than the other system. Also as well, too, it will, and there's another mode as well, too, that will also give you turn-by-turn directions. So if you're on an operator on a new route that you're not familiar about, or if a control or dispatch gives you a reroute, it will help you navigate the reroute. Also, you may want to notice on here as well, too, is there's a near-miss button up here. We collect detailed information on all of our collisions and analyze it and look locations. But the thing what we're really missing are the ones that don't happen, the near misses, the ones that happen. So what we want to do is collect information before the collision happens. So we're working with our operators to be able to push the button on that, get the location, a little bit more information on collisions that almost happened. So this is what the operator screen sees. And also, too, up here in the corner is a schedule deviation. So in this instance here, it shows the operator's about 2 3/4 minutes late. And it will provide them real-time information as they're going down the route. Okay, now we're looking at just, again, this is a system that's not quite, we're actually implementing it as we speak right now, and we only have about 100 out of 600 vehicles equipped. So these screenshots are just of those 100 vehicles that we have. So what this is a screen that the dispatcher has that will show real-time status of all the buses on a route. And you can see we only have it on a few routes right now. So let's take a look at the line 72, which is right here, the line 72. So right now we have actually 8 out of 16 buses that are operating with this system right now. But out of those 8 buses, it will give you how many are on time and how many are late. And then if a bus is running early, like on the 67, we have a bus that's running early and the ones that's running the most late. So this is a real quick, easy way to see route by route by route which routes that may be having some on-time performance problems in real time. Because in the peak hour right now, we only have about 5 dispatchers for, what do we have, 100 routes or 600 buses. So they really need to focus on the things that they can fix in real time. So this is basically a screen that will be able to help them analyze and look in real-time information on the route level. So this is something we've never had before. The next thing that they have is, again, I know this is quite small, but this is be able to see is a what they call it, a route tree, a headway tree. So this will show you real-time location of all the buses, and this is something this was one of the ones last week on the line 72 that I pulled out, and it will show you. Let's take an example right here. So if it's green, that means the buses, you can set the threshold any way you want, but it pretty much shows that the buses are on time at this point. And if they're light blue, they're a little bit late, and if they're dark blue, they're really late. So what you have is the position of the bus where it is now, but where it's supposed to be. See, this bus here is running behind schedule, and it's really supposed to be there. But the headways aren't too bad because the bus in front of it is actually running a little bit late. But then you can see here, this bus is running really late, and there's a red down here as well, too, which indicates, I'll get into that, but indicates there may be another problem. But it really shows you route by route where the real headway management and where they really are. And what's interesting about this system as well, too, is that in part of the system, we're getting automatic passenger counters on every single bus. We've had automatic passenger counters on about every new bus that we've bought since about the 2000, but we're still had some of our older fleets without as many automatic passenger counters. So this will have, we're upgrading, so every bus will have how many people are on board the bus, and this will give you that information in real time. So the dispatcher can click on it, be able to see exactly how many people are on the bus. And here's an instance where that would be very useful. I zoomed in on the bus that was running really late. And so what you see here is it gives you the information that this is red. And what that's telling you is that there's not enough time for the bus to get to the end of the line, have an adequate break, and then leave on the next trip. So that's something we've done. We've done a lot of research with Miguel on bus bunching and Jim Strathman as well, too. And one of the things we primarily found is that in order to prevent bus bunching, the best thing you can do is have everyone start right on time. And that's the key, and that's what we're really emphasizing and using the system to be able to do, is to see if we can get the buses before they get late and start on time. So that's what this would show right here. And then the other instance as well, too, if you had the real-time passenger counter information, you could take a look at the load, see that there may be 1 or 2 people on the bus. Okay, maybe you want to drop off the load once they catch up behind and they can deadhead to the end of the line and start on time. Or if you can take a look and say, well, there's still 20 people on bus, let's do drop off only and be able to catch back up. But this is something we can do a little bit more now in try to do a little bit more preemptive. Another one real quickly, I thought this was a cool screen to give you an idea, and it also leads into the data as well, too. This is a screen that they can pull up on individual bus. So they can actually take a look. So this is the bus we are looking at, which is right now at 82nd Cooper at 936. Well, it's supposed to be down here at Glencoe. And so you can see they get real-time information of where they are and where they're supposed to be. And you can also take this information and scroll back up and look historically throughout the day and say, did they leave on time? Maybe they didn't. Maybe we should send them a text message and say, hey, reminder to take a look and leave on time. So this is something else that they've never had as well, too. Something else, and this is very important for TransitTracker and real-time information, is they can actually do reroutes inside the screen now and do a reroute change, and it automatically sends the route to the bus. So here's an example of where they can go into the map screen, pretty much make a little detour where they can say, okay, now we're going to detour. There's a blockage here, so I need to route the bus around. That sends the information downstream system, so it'll send it to the bus, so they'll have the new route, but it also will make adjustments to the schedule, and TransitTracker will know too that this route, this stop isn't going to be served anymore, and we'll be able to cancel that stop, so you'll get more information. Because the way the system is right now is it really doesn't know. There's no linkage to some of the systems. If a bus breaks down or something, it doesn't really know that's doing. So that's why sometimes you'll see schedule time. You'll see 5 minutes, 5 minutes, 3:30, 4:30, or 20 minutes. Pretty much, we're not sure what's happened to that bus. That bus has been not transporting. Maybe it's been mechanical, or maybe our system is so old as well too. Maybe there's some issues with that. But this will be a huge enhancement to us, primarily for downstream and TransitTracker. And again, this is another way they can cancel a route too. So this will be, let's say a bus breaks down, and we know for sure that they're going to be canceled. They're going to have to send it back to the garage, or a mechanic's coming out to do it. What they'll do is the dispatchers now will go in, look at that route, will highlight all the stops along there and say turn it, and they can cancel stops, do a curtailment, all the different options, detours, and that will send everything down to downstream systems. So this is a huge improvement that the customers will be able to see in passengers. So now I'm going to get into the CAD AVL data. So you've seen a little bit of what the dispatchers will do and some of the data elements, but there's two types of data, actually 3 types of data that's coming from the system. We have real-time information that's coming back from the vehicles to the buses. And there's the 30-second polling data, which is basically every 30 seconds it pulls the bus's position, sends it back to central dispatch control. The central control does the deviation of how late the bus is or on time, and that determines how TransitTracker works. So that sends the information on TransitTracker. So that works every 30 seconds. TransitTracker updates its position. The other information we get in real time is called the packet data. And that is whenever there's communications between the bus, or as I mentioned, when the buses are going by the stop, it sends information back to help the dispatcher do information so they can do their dispatching, and shows the location of that. So there's really 2 types of real-time information. And lastly, the information that in operations analysis that we get to play with is the vehicle log data. So this is on every single night as the bus goes along its route, it collects all this information, and then at the end of the night, it basically uploads it to our servers, and we'll have all the information of historically as what the bus has done before. So we have the stop level data, which is basically every time a bus passes by a stop, it records the information, passenger information, time, anything else, lift usage will show, and that gets uploaded. But something new that we've had, this is something new that we're getting with the new system, and this will be great for doing a lot more detailed analysis of kind of signal priority and other stop information, is what we call the 5-second breadcrumb. So every 5 seconds, it reports its location that we're going to be able to do. So every 5 seconds on the vehicle log that will get updated, we'll be able to know its exact position. So for example, if we're looking at some signal priority issues or some queuing, we'll be able to see at a 5-second level whether the bus has been moving or it's been stopped or how far it's been moving. So this is something new that we've never had before to be able to do a little bit more research on. Again, so just on the stop level data, this briefly the type of information data that we're collecting, and this is very similar to what we're collecting as the old system. So we've had this information for about 15 years, but there's a little bit more enhancements I'd like to talk about that we're getting. So of course we know the route number, the direction, the trip, the date, the operator, the bus stop at location ID, as I mentioned, every time it passes by a stop, it collects data, and it collects this information. It collects the arrive time, the leave time at the stop. And then we have a schedule time for every stop, so we can do schedule deviation by stop. And as again, I mentioned the automatic passenger counters. We now will have 100% passenger counters on every single bus. Before, we've had about 75 to 80%, so this is a huge enhancement for us. We're very excited about it. It calculates the passenger load. It knows whether or not it served the stop, how long it dwelled at the stop, whether or not the lift was deployed to pick up a wheelchair. Speed, we're able to calculate speeds in between stops, as well as everything has a latitude and a longitude to it, so everything is able to be geographical analysis. Can everybody see this okay in the back? Because I have a blow up if it's kind of small. But this is an example of the data that we're having. So this is something from last week on the 23rd. So this is block assignment 941. So that's every bus has an assignment, and this is the assignment for 941. So I did a snapshot between 7:07 and 7:13 of the stop level data. And so here we can see the bus was actually at Powell and 55th. It was scheduled at 7:02:12. It arrived at 7:09:44. And that's the time. This is one of the enhancements of the new system, is that the old system was done kind of, there was a circle around every stop, kind of a virtual GPS circle. And when the bus entered the circle, it knew what time it arrived and what time it left. Now with the system, it's a lot more accurate. Basically, what it will do is actually comes up and determines exactly when the door was open for the stop and when it passes by the stop. And when it starts to leave the stop, it's actually right when the wheels start moving again. So this is a lot more accurate, detailed information than what we've had in the past. So that's what this is showing here, is the actual arrive time and leave time. There was no one got on, one person got off, the load was 36. The door was open for 15 seconds, and the bus was moving 27 miles an hour from the prior stop to this stop. Now, you'll see some blank records in here. This is new as well, too. The old system only recorded data whenever you passed by a stop or opened the door. The new system, actually, it's not really a motion detector, but it's whenever the wheels stop, it records a record. So we'll be able to tell if a bus was stopped in a signal, and with the 5-second breadcrumb data and this, we actually can do movement by movement by movement and get an idea of what the buses are really doing on a small localized level. So here's an instance where the bus was traveling between 55th and 52nd, and you can see it was actually stopped from 7:10:26 to 7:10:53. And I'm sure enough, if we pretty much put this on a map, you can see that it was probably stopped at a signal waiting on a light. The other thing I want to point out as well, too, here is so you can see the bus was actually traveling along, and then right here, it's 7:18, actually at 33rd, right here, you can see there was a passenger load of 64, and at that time, at 7:19:38, right before they left, the operator reported a pass-up overload. Basically, the bus was so full, she couldn't get any more people on board the bus. This information is logged as well, too. So we're able to take this information along with the passenger information and do some capacity analysis, which I'm going to show you here in a little bit. Okay. So there's just a blow-up of it. So what I want to do is kind of go into a couple applications. And I thought as you can see, that there's a multitude of analysis and reports you can do with all this data. So what I thought I would do is just show a couple examples. And one of them is how we use the information to do our capacity and passenger load analysis. So first of all, before we start, I wanted to show how we determine passenger capacity and what our levels of overloads are. So you can see we have basically 4 different bus types. We have a small bus. We have some 30-foot coaches out there that have 28 seats. The design load from the manufacturer says that you can only get 35 on there. But what we always do is we do an 80% of design capacity, which is called the achievable capacity. And the idea of the achievable capacity is that it's still crowded enough that people are discomfort and over, but there's also still a little bit more room to grow. We don't want to be we don't want our standard at the design standard where it's jammed and full. So what we want to do is kind of know about the idea and have our reports alert us to before we get too much crowding going on. And so that's why we use the achievable capacity, which is 80% of the design load in our standard. A low floor bus, we have the exact same standard of 51. So there's 43 seats on a high floor, 39. So basically our standard on a typical 40-foot bus, our typical bus is 51. So that's 39 seats and people 12 standees. Once we get above that, that's when we start having issues, and that's when we start having our factors of our service standard. And again, on a light rail vehicle, this is per 1 car. So there's 64 seats on it. The achievable capacity is 133. So that gives you an idea on the max. This graph here is one of the things that I always say is the benefit. I've always had the question, people asked us, why do we have so many passenger counters? Can't you get by with just doing a sample about 12 or 15%? I'm like, well, the real reason why we want so much more is because I really want to be able to do headway to load capacity. I want to be able to tell when the buses, when the buses are overloaded, what was the actual headway. And I want to know what the load was on the prior bus as well, too. And so what this chart is able to do is showing us that. So this is the line 14 in the morning. So this is a peak hour between 7:58 and 8:57. Each one of these is a bus observation. So you can see here on one day, we actually had some really crowded buses that were above 70. And then down here is the actual headway. So in the peaks, on the line 14, we're running 6-minute service, so 10 buses an hour. So what this is showing us is how close the deviation was, how far. So when you're talking right here, that means you got 2 buses that are back-to-back. And this is the front bus. And then here's the lower bus. So this is the bus that actually has a larger gap behind it. And what you can see is a great linear relationship between buses that are the follower versus the leader in headways. Pretty much. And what it shows is that, and what we do, so we take this into account when we look at our passenger counters. We want to know, okay, what was the headway? And that's what this is showing us. So if you do, I keep forgetting I have this, is that what we want to do is be able to say, okay, what would the load been if the buses were right on time? If we had perfectly headway. So what you do is you can see that this bus is overloaded, but if they were both right on time, it would be down here. It wouldn't meet our service standard. In the same way, too, the underloads, the bus that was not carrying anybody would have been up here. So what we try to do is take into our report is the headways, to really look, are the headways evenly spaced and on time? Because the last thing we want to do is if everything is we're getting overloads only when the buses are crowded, is add more buses out there. Because what that is going to do is it's a waste of resources. We'd be much better off spending money getting all these buses on time and working on the schedule side than actually adding services, so actually extra buses. So this is kind of what example how we do it. So here's a report that we use to show that. So this is the line 72 from this fall. So this is something within the last 2 months of collecting data. And what we do is we look at peak hour. So we go hour by hour by hour, but we do it every minute. So every possible hour, we take a look at to see are we having crowding within that 1 hour period. And we take a look at the average. Typically what we do is look at average loads. And then we also look at 70th percentile loads, too, because we want to take a look. We know that every day is not average. There's some days where it's really crowded as well, too. So we want to look at the variability of the loads. So here you can see that we're actually running on average. We're overall during this peak hour, we're a little bit below our peak hour or achievable capacity. We're running about 84%, but it's still pretty high. It's still alerting us that we may be having some capacity issues here. And then if you look at the individual buses, so these are individual buses running at the peak load point is 82nd of Powell, and you can see that the 39, 41, 43, here's a bus that's averaging our right at our achievable capacity. So here's a bus that's really crowded. But if you go over here and you take a look at what I call percent headway caused, and those are the ones that are out there on the fringe. So the overloads that are way out there where we had gaps in service, there were 78 of them. 78% of those overloads were caused by bus bunching, that if the bus was on time, that wouldn't have had the overloads. So instead of focusing, so this is where we'll give the information to our dispatchers in real time so that they can monitor the situation. So they'll be able to proactively take a look and see if these buses are evenly spaced and try to fix this without us adding extra service out there and extra buses, which are very expensive. So this is a real quick, easy way, an example of how we do a load capacity and how the automatic vehicle location and the APCs work together. Here's another graphic. I love this graphic, and the intent on this is basically what we're looking at are average loads by station. And so what we have is this is max. So we're only looking, and you got to read this from going from right to left. So this is going from Gateway out to Hatfield Government Center in the PM peak. So these are all the max trains, and you can see here's a red line train, blue line trains, and what this does is visually shows your loads and how loads and how far people are basically how far people are having to stand. So what you see is anything light green is really low. Dark green means the loads are getting a little bit higher. Yellow means we're having standees on average. Red, orange here is above our service standard. But the idea here is you can see how far, when the load starts, when people are standing and the issue, and how far it is. So it's going out. So this gives you an idea that our loads on average are happening out to about Merlot Road and 185th. However, what you see is not every train goes out to Merlot Road and 185th. So what we've done in the peak hour, as you can see, here's an example of that. So what we've done in the peak hour is, if you notice, going back, that there were no red line trains in here. So in the peak hour, we run all the red line trains from coming in from the airport all the way out to Hatfield Station, so to help with the crowding. And this is one of the reasons why we looked at, because we can see the majority of the people want to go beyond Beaverton Transit Center. And you can take a look at that too, and the idea is we probably want to extend this earlier. Right now we started about 4 at Pioneer Square. You can see about the first blue line, right around 4:30, 5 o'clock is when we start moving this, every other red line or every red line train going out to Hatfield. But you can see we're actually having really crowding problems before that. So what we want to do is figure out some ways to be able to increase capacity going out. And our long-term impact, or our long-term, is to basically have make some changes at Willow Creek, so we can actually have trains, red line trains, lay over at Willow Creek. Because you can see, if you take a look at the red line train as they leave, our peak load point is Goose Hollow, westbound. The blue line train is 189, the red's 87. 180, 127. You can see there's a big difference there between them. So what's happening is there's people want to go beyond Beaverton Transit Center, and this is a real quick, easy way to analyze and view that. So this is a different way, and we have Automatic that does this for every route as well too. But this is just a good visual tool of using the passenger activity. Lastly, I just want to talk about schedule reliability. I know in 2 weeks, Ken Zadarin from Service Planning and Scheduling will be here to talk about our service standards and how we use the data a little bit more for scheduling. But I just wanted to give a quick example of some running time data, because you can see we have data from every stop to every stop, and we provide information reports onto scheduling on that. But I just want to show how difficult scheduling really is, and how variable the running times that we're seeing from the data. So this is PM peak. So these are actual running times. So this is end-to-end running times from the PM peak, so a 2-hour peak in 4 to 6 p.m. So a bus starting from St. John's going all the way out to Gresham. So typically you would think running time should be very similar for this time period. However, look at the range of variability. We have a trip that takes 105 minutes out to 132. So really get an idea of the variability in running time. And from the data, we've done a lot of research with Dr. Strathman to kind of look at the operator's impact and the environment on it as well too. But I think this graphically really shows how variable things are from day to day out there in the running times. So another example report we provide to scheduling that they use is everything they schedule from time point to time point that's in the running time, or in the scheduling book. So here's an example from the Route 4 division, Fessenden outbound from Spring. So this would be running times between Southwest 5th and Salmon to Division and 12th. So we're starting at 5:17, running out to 6:58. And so you can see it was scheduled for 12 minutes at the peak of the peak, and then it goes down to 11. And we're actually provide them, you can tell, we get information. So we look at the median running time to be able to do the 20th and the 80th percentile, so they get an idea of the variability. We also keep track of the average ons, the passenger, so you get an idea that this one's probably taking, maybe taking a little bit less because it's picking up less passengers. The average max load between it. Average speed is important as well, too, because we're using this information to write schedules, and they go out and validate and verify as well, too. But if we see somebody who may be operating a little bit faster, we don't want to provide a schedule that's for operators that may be running behind. But also, too, you get an idea of the percent late as well, too, the variability that they have in scheduling. So this one's averaging 29% late, 4.1 minutes. But this one down here is actually 10% and 1.9. So this is just kind of an example of kind of the data that we use, or some of the different things that we're able to do with the information. I think Dave, now we've talked about a little bit more, but there's a lot more applications, and Dave's going to talk a little bit more about some other operational analysis that we do with the data, some more project-related information.
Okay, I'm going to talk a little bit about some of the ways we use the data. Yeah, I need that. Thanks. So this is a map that we generate from using data that starts with what the driver is indicating in the bus. It's fare evasion. So when someone gets on the bus and they don't pay a fare, the operator, rather than saying you have to pay a fare to get on the bus. It's more like they just inform them that you have to show proof of payment, and so they indicate on their display that I had a fare evasion at this location. And so what this is taking over the period of a month and taking that data, and then since we also have a geographic component, we're able to map that. And one of the other purposes of having the fare evasion option for the operator is so that in real time, that message will go to the dispatcher in real time to say that I have a fare evasion at this location. So it's conceivable that if there were some fare inspectors in the area, they could actually intercept the bus. But that's kind of one of the other reasons of having that data. But this is kind of a good example of how we can take data and display it in a lot of other ways. So then with transit signal priority, it's something we've been doing at TriMet for like 10 years now. It's been quite a while. And basically, the idea with signal priority was to move more people through an intersection rather than just vehicles. And so some of the ideas we have to reduce transit running times, but also improve the reliability of this schedule, which I'll show in some graphs, and that's basically what Steve kind of touched on, is to reduce some of that fluctuation from trip to trip so somebody riding the bus can kind of depend on when their bus is going to get there. Also, by doing that, we hope that we could maybe save a little bit of money by not having to add so much time into the schedule to account for that variability. So basically the way it works is we use the automatic vehicle location system to figure out whether the bus is late or not. It's one of the conditions that's required for the bus to actually get priority. But so if the bus meets conditions of there's various conditions, including being a certain amount late, being within the city of Portland right now, that's where we have the system, then the bus can send a message to the signal requesting priority. It's not the same as like when an emergency vehicle gets a pretty high level of they call it preemption. We're just basically kind of like sending a request saying, well, if you can grant some extra time for the bus to get through, whether you turn the light green sooner or you shorten the red time, go ahead and do that. And then once that's granted, supposedly we would get through. So that's kind of how it works in a nutshell. But also one of the nice things about the signal priorities, we can then work with, like we're working with Dr. Figliosi with studies on what impacts is that signal priority having on the buses in aggregate, and are we really able to show some improvements? And also that's a way to keep that information going. So this is an example of how we looked at a small segment of Barber Boulevard. We're running line 12. This was a number of years ago. But basically what this is showing is all the different, kind of what Steve was showing earlier, how long it's taking different bus trips to get through an area. And so one of the things here is that we're having to add time in the schedule to account for all this variation. So we're actually adding all the way out to 104 minutes of our time for this. And so what we did is this is without signal priority. Then with signal priority, we found that the variability was reduced so much that we were able to actually shorten the amount of time we had to schedule. And that's kind of an illustration of how we could save some money through not having so much time in the schedule. So that kind of keeps that variation from, it used to have some trips that were taking this long. Now we've kind of collapsed that down, and so it's a much tighter distribution.
Oh, okay. I just want to mention this, but okay. This is something new that we've be able to get through the system, is that we've worked with the vendors, and many other agencies have this as well too, but we're actually going to be able to get some real-time information from the drivetrain. And that's on board the vehicle and maintenance data, as well as it's going to log all this information as well too. And just some examples of it is, it'll be able to know where the throttle position was. It'll actually be able to give us a little bit better information on fuel economy, coolant temperatures, if the anti-lock brake system was activated, oil pressure, fluid levels. So a lot of things that's in the drivetrain now, you'd be surprised, at least I was, of all the components and software and everything that's on board on the maintenance side now can be tracked and be able to use. So this is all information that's going to be able to help us maintain our vehicles a little bit more. And nice is they're going to be able to have some of this information in real time. So if they do get a request that a bus is having problems, they'll be able to go along to the system and say, oh yeah, look, the coolant temperature, that's the problem. So it'll give the maintenance tech a lot more information going out into the field, as well as our maintenance analyst, who's in the back of the room, by the way, if you have any questions, will be able to analyze this and do a lot more improve. So, is that oh, it's right here. So as I mentioned briefly, we've done a lot of work with Portland State and researchers using the data. So this is just some example studies that we've done. I think over the last 15 years I've been at TriMet, we've done at least one study every year and more. So we've also provided lots of data to students as well too. So I'd encourage you, if there's any class projects or anything, we actually are very happy to work with students on providing data and do a little bit more. So we're very excited to do research. This was one of my favorite things of working, is doing the collaboration we have with Portland State on our research projects. That's kind of it in a summary. So I think we have a little time for questions. I keep looking at that clock. I think we need to fix that clock.
So we need to update the clock, and we need to update the microphone, because we have only one. And to ask a question, please use the microphone.
What?
So you mentioned that TransitTracker would now know about detours. For those of us who consume your web services, what other goodies is this going to give us?
I think the main thing is that it will be able to know on snow and ice, for example. We are actually programming in all the snow and ice routes. So before, when a bus did that, we didn't know. But now we actually have routes coded with those, with schedules. And so that should be working as well, too, in theory. We have to wait and see, it works. But that's something that should definitely be an improvement on TransitTracker snow and ice. But again, primarily I think the biggest improvement is, when you see schedule times in there, again, we've had so many problems with our existing system. It's 15 years old. For example, our existing system uses PCMCIA cards to put in all the data. Well, they have to be 1 megabyte cards. We haven't been able to get 1 megabyte PCMCIA cards in, 5-6 years. So I think we bought all of them we can on eBay that was available. But our existing system isn't really supported anymore. So that's part of it as well, too. That if you do see schedule time, it's pretty much that either we had a bad data card, or maybe the bus is broken down. But that would be the biggest improvement, is to be able to see when a bus does actually break down. We haven't quite decided exactly how that's going to go out, if it's going to show canceled or something, or just maybe take it out. But that's going to be a big improvement. Yes, I'll go in order.
Just a quick question. You talked about the automatic passenger counters.
Yes.
How do they work exactly?
Well, we've had automatic passenger counters at TriMet since 1982. We've been one of the leaders in this, and the new actually we're upgrading with all new technology, because we've been using the same. And for the old technology, if you go out on an old bus now, what you'll see is there's infrared beams on the side of the door. So they're basically, and it knows which beams are broken first if you get on or off. But the new ones are going to be above the door, and they're a lot more reliable, but they're passive and active. So it really measures body heat. And we've had those on the rail vehicles. We actually have been working with those on the rail vehicles on all the Type 3s, 4s, and 222 is retrofitted on the Type 2s. But we've been working with those for about 8 years now. And the vendor is trying to sell me the new laser passenger counters that actually have lasers coming down, and he showed me the visual, and you can actually see people moving in and out, and they're very accurate. So hopefully we'll be able to go to those in the near future. But yeah, it's interesting stuff. Go ahead, Miguel. You can pick.
So my question is, with the new interface for operators, that's slide you showed with near misses, is there more time that you have to spend doing specialized training with the operators now?
Definitely, yeah. Right now what we've done is all the operators have gone through a couple-hour trainings just to be able to log on the system and be able to use it. And we anticipate once we get it all up and running that every operator is going to go back through and do a lot more detailed information training so they'll be able to use all the extra features, like I mentioned, turn-by-turn directions if you're on the extra board and you're in a new route. But yeah, there's been quite a bit of training. But right now they've just been kind of trained on the initial to get it up and working. Because it's only on, right now, I think last week is 100 buses, I think we're up to now, out of 600. Yeah, I see nodding. Go ahead. I don't care. You pick, Miguel.
Thanks. Hi, my name's Rich. I actually work for AAA. I've been a dispatcher on AVL stuff for about 4 years.
Oh, good.
And I think we like it a whole lot. But my question was, do you find that there's a reduction in verbal communications between the drivers and the dispatchers? And how have the drivers been responding to using AVL?
Well, like I mentioned, we've had AVL since 1997, so it's really not a major change for them. At first, it kind of was, but for the dispatcher, it's so much better, and I think for the operators as well, too, that they can just punch in their issue into their VCH, such as, mechanical lift is not working. They just push that in there. It comes up in the queue, and if it's their role in the middle, it just comes to the top, and they'll get answered real fast versus, an operator who just wants to talk about, something. So for them, it's basically, I think it's much better, and they've been used to it very well. So this really hasn't been a major change for them. And so pretty much every operator now we've had for years have been using this system. So that's on the good side. Oh, what?
So you mentioned that there were 100 buses out of your 600 that were using this system, and I'm sorry if I missed this, but how did you determine which ones would benefit from the system? Were there equity conversations, or how did that pan out?
Okay, maybe in the back there we can have Curtis help answer that. He's our bus maintenance analyst. That's why I brought him.
Well, initially, when we started this program, we actually started a pilot fleet taking samples from every one of our fleets before we actually just went out and bought kits so that we could actually check our drivetrain communication systems on the buses along with the interface and how we're going to mount this system on the bus. So a little bit of every fleet has them. And also, we've just been taking in our brand new fleet, which we specified to only be equipped with the brand new radios. And that's 50 of them right there. So that's half of them. So that's how come we only have 100 rolling right now, and we're still in the process too of installing. In the end, all 607 buses will have the system equipped.
But yeah, I don't think right now there's no priority on getting fleets out there working. We're working on getting all fleets up and running, I believe. So yeah, it's because even all the old buses, even the ones that we may retire in the next year or two, have to be equipped.
I was just wondering what specific conditions have to be met in order for a bus to receive signal priority.
Right now, it's pretty much any bus that's running, if it's running 1 second late, it will request priority. However, if a bus if it's not running early and it stays on till I believe it's 30 seconds late, it'll request it. So the idea is, and we talked about this with the city of Portland and the traffic engineers, and they were basically we've been very fortunate that they've been very excited in working with us on this. But they claim that we don't want the bus to get too late, because if it doesn't, once a bus gets more than like a minute late, it's hard to catch back up. And they also remember as well, too, there's passengers downstream waiting for that bus as well, too. So we want to keep that bus right exactly on time. So it's right. As soon as it gets 1 second late, it's going to request priority.
Interesting. Thank you.
Yeah. But we don't want to have it due early as well, too, because we've seen one of the effects we saw is that when we first turned it on, we just had it rolling, and operators would tend to get a little bit early, and what that means is the buses behind it get a little bit later, so that's why we've worked on the thresholds.
I just had a question. Is there any way to, in the peak areas, peak usage areas, to put a display for the passengers to see, okay, this bus is going to pass me by, so that you don't have passengers getting angry, things like that? Just a simple display or an auditory outlet?
That's a good idea. I mean, one thing with the new system, we will know if the next bus has been going in to pass up like I said, the pass-up overload. So what they were going to do is they were going to go start doing drop-off only. So that's a potential. We do have that information, and whether or not we can actually, I think we probably might be able to send that out in TransitTracker. Plus, they've also been talked to about putting out the passenger loads in real time as well too. So putting that with TransitTracker, so you'll have an idea how many people are on this existing bus versus the next bus. So you can, if there's two buses close to close, maybe next to, you can make a decision. But that's a good idea. We can take a look into it. I know it's been discussed as far as the passenger load, but as far as, you know, but the good thing is it will, like I said, though, if they do go into drop-off only. They go to that curtailment, is that what they do, and they let it know that this is being curtailed from here to here, and that will take it out of TransitTracker until they decide to go pick up passengers again. So it should be in there. That's the system as well, and that's one of the enhancements of it. So you should know that this has been canceled, that trip, next trip.
Okay, thank you.
Regarding the priority, is it possible then to connect to the headway information for the current bus regarding like how its headway is with the bus in front of it or the bus behind it to the application of priority for that bus?
Yeah, we've talked about that and working with Peter Koontz at the City of Portland on doing something like that. And we'd want to do it only on routes that have real close buses going into headway mode. It's something that's been discussed.
Well, not necessarily going into headway mode, but rather, so there's logic to decide whether or not you request priority on the bus. So the question is, can the bus then use the information of how it's connected to the bus before and after it to either request priority or not?
Instead of doing the early late clock?
Yeah, exactly.
Yeah.
Or in addition to. Maybe you say if it's late and the headway is really short, right? You want to speed that first bus up.
Yeah. Well, that would require, right now, again, that's requesting priority unless it's running early. Yeah. So that would be something we would want to do. I think we'd only want to do that on routes where we let customers know that we're running headways on here, that pretty much if you're running in the peaks, if you're running like less than 10-minute schedules, that you shouldn't be able to, there should be a bus coming all the time. But right now, with having schedules only, I'm not sure we want buses running early when passengers expect a bus there at 7:06 and we run it early between 7:03. I don't know. It's something. I think it's a good idea, but it would only work on if there's really short headways. So, but that's what we can discuss. But, all right. Two questions.
I don't suppose you can tell how many open bus rack positions there are.
What's that?
How many open bus rack positions there are in the vehicle?
I'm not sure I even understand the question. Oh.
Bike rack, sorry.
No. No, unfortunately, that's not. We actually are having a lot of what we tried to do is our vehicle engineer pretty much said anything that has a circuit or any sort of switch on it, we want connected with the system. So we actually have the yield sign in the back of the bus. I think the turn signals, where we're going to be able to collect information on if they use turn signals. Unfortunately, there's no electronics on the bike rack. Otherwise, we could. But right now, we haven't seen any electronic bike racks. But pretty much anything that has an electronic switch on it we're collecting data on. So, yeah. So maybe work with the bike vendors on getting some detection devices on the bike racks. Anyway.
Yeah, I have a question about the real-time data set and the archive data set. So you mentioned the real-time data will be updated every 30 seconds. Is there any archive for that data set? And have you considered integrate that data with the vehicle log data? So because if you update every 30 seconds, I expect in the database every 30 seconds you have the bus position in the archive data.
Yeah, we do, and we do some of that now, but we don't have with the old system, we don't have 30-second update, but we do have positions, and we have used that. But the thing that we have now that we didn't have is we have the 5-second breadcrumb data. So we really don't need the 30-second updating because we have data every 5 seconds. We haven't decided how long we can archive that and keep that real time because that's a huge amount of data, as you can imagine. But we'll have the 5-second data available.
Yeah, I see in your example when you indicate the bus stopped at the signal, and each row is not every 5 seconds. I see it's about like
yeah,
1
that's
minute?
from the vehicle log data. So yeah, but it can imagine that vehicle log data, which basically records data every time it passes by a stop or whenever the wheels stop. So we have that data, but can imagine throwing on the 5-second breadcrumb on top of that. So you'll get an idea where they are, they're moving. So you get an idea, were they at a stop and moving? Then you'll be able to look and say, okay, they were moving from 5 seconds from here to there. So I think the integration of the two would adequately get what you're looking for their way.
Oh, okay. Yeah.
So we have a question from online, from the web.
Oh.
So there were some questions about the display that the drivers will see.
Yeah.
And how big is it, and in terms of how much information should be provided and how distracting it might be for the driver to have to drive and look at this screen, and what's the trade-off in terms of what you include in this screen versus what you shouldn't include in terms of.
Let me go back to the very beginning on that screen. So again, it's not as large as it looks on this on the screen here, obviously, but pretty much what that is a concern, driver distraction, and what we tell the operators is we really want them interacting with it when they're stopped. But there are times. But the idea, though, is that there were some trade-offs on the screen. We worked with the operators considerably and everyone at TriMet to be able to look at the design screen, because we did design this and work with the vendor. But they've had something similar to this for years with the early late clock. The only really addition on this information is the information it gives them on the next stop, which can be very useful to operators, and it will give them, in case be able to look. But that was something we did consider, and I really have the best answer for that. But it is a concern. Distraction driving definitely is a concern.
Okay. What last questions?
Another question about the TransitTracker system. How do you predict the arrival time of a bus at the next stop, just based on average speed and current distance?
No. Right now, it's deviation based. So as far as if a bus right now is running, let's say a bus is you're waiting for a bus. It's right now. It's 7 o'clock, and you're waiting for a bus at 7:15. And the bus is supposed to be there at 7:15. Well, the bus reports that it's 5 minutes late. So what it does is it assumes that when it gets to your location, it's also going to be 5 minutes late. So everything is deviation based on where it is now. So it sends its position back to Central. Central says, oh, that bus is 5 minutes late. It reports it off that it's 5 minutes late. So therefore, all the downstreams thinks the bus is going to be 5 minutes late. But it's updating every 30 seconds. So it's getting its position in every 30 seconds and updating. And the rail system works the same way as well, too. Again, the rail system, actually, we don't have GPS on the trains. Well, we do have GPS on the trains for the passenger counters on half of them. But the other one works with track circuits inbred every so often. So we actually have a schedule for every track circuit and every train, and it's sending back it varies from 5 seconds to 40 seconds on the location times between those loops. And it does the exact same thing as well, too, and it determines when the trains are going to be there. So
I think this is the last question. There was, a traffic accident, close to the Rose Quarter, some of the tracker info was lost for some time. And some of the another online question was, is there any measure that is going to be taken to prevent in the future, or what's the reliability of the system in case of something, big storm or something happening in terms of...
yeah, what happened on that situation, what happened there was basically a car, unfortunately a man, I believe, blacked out and ran into, and it hit the signal casing is what it hit. So it wasn't really, it was, the signal casing is the communications, for that kind of area, for the Lloyd Center area. I think it was pretty much between maybe 7th Avenue and part of Rose Quarter. So what he did is he knocked out the communications for that. So every time, when I mentioned every time the train goes over a loop, it just didn't know that it was where it was that loop anymore. So we're actually gone, I think we're almost ready that's been replaced and going. But that's what happened there, a situation of there. And that could happen anywhere as far as, it was, I don't know how, if you take a look at the location of where that signal casing was and how he came through there, it was a miracle that he actually squeezed right through there to hit that anyway. So Yeah, I'm not a rail engineer on locations of those boxes, but I think most of them are, again, that one's been there since 1980, how long? And so, but yeah, on that one it just hit the communications.
Thank you very much, Steve, Dave,
right.
and for the presentation.